in two variables. What this means is that now our equations don't have equal signs, but they have our less than equal, greater than equal symbols. It can be written in standard form as well as slope-intercept form. The only difference will be that instead of an equal sign, we have an inequality sign. When we are finding solutions, we can plug in an xy and see if it comes out to be true or false. So here we have an equation, 4x minus 2y greater than or equal to 8. And we want to know, is 3, 3 a solution to that equation? And or is negative 2, negative 9 a solution to that equation? In order to know if something is a solution or not, we're going to substitute it in, and we're going to see if it's true or false. So for this example, we're going to plug in 3, 3, 3 to the x, 3 into the y. And we're going to see if that solution comes out to be greater than 8. So 4 times 3, we get 12. 2 and 3, we get 6. Greater than or equal to 8. Well, 6 greater than or equal to 8 is false. So, no, 3, 3 is not a solution. All right, so try it for negative 2, negative 9. We're going to plug in 4, negative 2, minus 2, negative 9, and see if that comes out to be greater than or equal to 8. Well, that's negative 8 plus 18, which is 10, and that is true. So yes, negative 2, negative 9 is a solution. 3, 3 is not. And it's just that simple. If you want to know if something's a solution, you plug it in. If it works, great. If it doesn't, then it's not. All right, so to graph these, in order to graph, we are going to put them in slope-intercept form. That means we're going to graph them the exact same way that we do if it had an equal sign. We begin with our b and we move our m. You need to do your m at least twice, sometimes more, especially when we get into multiple equations. Just like inequalities when we were solving, we had open circles and closed circles. Well, when we're graphing, obviously we don't have circles, those are on a number line. But in a graph on a line, we're going to have an open line or a closed line, or solid, if you like. So if it's less or greater, then we're going to have a a dashed line, an open line. And if it's an equal to, it's going to be a closed line or a solid line. Same relationship as if it was a circle on a number line. They have that same relationship. Well, when we did a number line, we had to look at, was it an open or closed circle, but then we had to shade all the true solutions. Same thing has to be true on a line. You are going to shade according to the symbol. If it is greater, we shade above. If it is less or less equal, we shade below. And we're going to look at a few examples here. All right, I don't have graph paper with me right now, so I'm going to have to draw mine. But you'll have graph paper, so you will have yours nice and blocked out. And remembering each block is a unit. Here we have y greater than 3x plus 1. So I'm going to start at x plus 1 on the b. I'm going to move my slope 3 over 1. So rise, 1, 2, 3, run 1. And reverse it is to go 1, 2, 3, and 1. When I connect these dots, I need to connect them based on equal to or not. This is not equal to, so that means it is an open line or a dashed line. And then I need to shade the true solutions. I need everything greater than my line. So my line, greater, common sense, is above my line. This would be below the line. And shade. Okay? Let's try it again. Y equals negative 1/2 x. There is no b, so I'm going to start at 0. Negative 1 means down and to the right 2. And reverse 1 and 2. If I need to keep going, that's fine. Especially, like I said, when we get into doing 2, 3 equations, you're definitely going to want to extend out your lines. 3 dots is probably not going to be enough. I'm going to connect these dots with a solid because of the equal bar that's in here. So I'm going to connect solid. So there's my line. And I have y is less than or equal to. So less than my line is below. Now if you want to color it in and shade it like we did over here, that's fine. But generally you're just going to see me do some arrows just to make sure you got it figured out. All right, let's try our specials. Y is less than 4. Well, the fact that it's a special and it's a y means that it is a horizontal line. The equal to tells me that it is a solid horizontal line. And now this one's really obvious, above and below. Less than tells me below. And so I shade below. Now when it comes to a vertical special, x negative 2, so there's negative 2. It's special because there's only an x, there's no y. So that tells me it's a vertical line. That vertical line is going to be dashed because it is not equal. So there's my dashed line. This is the only one that doesn't have above or below. It has the common sense left and right. If you're greater than negative 2, are you left of it or are you right of it? Well, we should know that greater than negative 2 is to the right. So that's how we're going to solve and shade and graph our inequalities. We graph them the exact same way we do a line. The only thing is we have to pay attention, is that line open or closed? And then we have to shade according to the symbol that is given to us.